Hey, AP Physics, this is 1995 M1 and this is Horner. Let's go through and do this little problem that we have. We have a cube. That cube is moving at 26 meters per second towards the ball on the edge of a table, and it strikes that ball and then they both fall on the floor. So they make some trajectories down. So it tells you a little bit about that here, tells you how high it is, how wide the table is. And then on this picture, it shows you a graph of the force exerted by the ball by the cube as a function of time. And the first thing that they want us to do here is just to go ahead and find the impulse given to the ball. So the first thing we need to do is recognize that, remember, impulse is basically just J, and that's equal to F delta T. And so we do have a force, we do have a change in time, and what we need to do is to separate this guy into several different geometric shapes. So here we've got a really bad rectangle, and then we have two triangles, but you'll notice both triangles are the same. So when we do this, we're just going to say J is equal to 1/2. We see that the height is 2. And then the base of this triangle would be 4. And we're going to actually take that whole thing and multiply it times 2 since this other one is the same. And then we'll add it to the length times width of the rectangle. So that'd be 2 times 2. Okay, sorry. Yep, that would be 2 here. And then notice that this is also 2. So this would be 2 times 2. And if you do that, you should end up with the right answer. So this is equal to 4 times 2 is 8. Half of that would be 4. 4 times 2 then again is 8. 8 plus 4 would be 12. So this is 8 plus 4, and that would be equal to 12. Notice that these are in times 10 to the third newtons, and this is 10 to the negative third seconds. So what you could have done is just cross those off, and then you just have newtons and you just have seconds, and it works out really well. They do that sometimes to try to confuse you. So if you see the exponents are with the same, but one is negative, one's positive, just cross those out. You don't need those. Next thing it wants us to do is figure out what is the horizontal velocity of the ball after the collision. So this one should be relatively simple to do. We know that impulse is really just equal to the change in momentum. We know that the impulse here was 12 newtons times a second. That's equal to the mass of ball B times the change in velocity of ball B. We do know that the mass of ball B is 5 kilograms, and we know the change in velocity would be the final velocity minus, and then it was not moving initially, so that's 0. So go ahead and put our 12 in here. At this point, you should be able to do your math and come up with the correct answer. And your correct answer here for the final velocity of B should be equal to 2.4 meters per second. And that is the second part of the problem. That's letter B. Let's go ahead and take a look at letter C. So when we move down to letter C, it says determine the following for the cube. So this is our first object. So for the cube, immediately after the collision. So we need to know the speed of the cube, and then they want us to find, is it traveling to the right or left? If it's going right, our value for speed will be positive, and if it's going left, our value for speed will be a negative value. So let's go ahead and do this. We know the change in momentum is the same for each object, so we know that your impulse is equal to change in momentum, and because we're looking at the object going, and it's different in that we have the cube hitting the ball was 12 for newtons times a second for the change in momentum, so the cube has got to be negative 12 newtons times a second, because those two should be equal and opposite in order for this thing to work out right. So let's go ahead and we know that this is negative 12 newtons times a second. That would be equal to the mass of the cube times the change in the velocity of the cube. The mass of the cube, oops, let's do this down here. The mass of the cube was 0.5 kilograms, and we know that the final velocity minus and then it is 26 meters per second is what we need to put here. So if we go back up, we'll see that its original speed, if you remember, move this all the way back up, was 26 meters per second. So we see that velocity, that original velocity up top. So let's move this back down and go ahead and solve the rest of the problem. At this point we have negative 12. Negative 12 is equal to 1/2 of VF minus 26. If you go ahead and work through all that math, you will see that that should be your final velocity of the cube is about 2 meters per second. I didn't go through all that math. You should be able to do that no problem at all. Notice that it is positive, and so because it's positive, we do know that it is going right. You don't have to explain that or anything else. It just says, is it its direction of travel, is it right or left, if it's moving. For letter D, they want us to find the kinetic energy dissipated in the collision. So remember, a lot of these collisions, unless it's totally elastic, then the objects will lose a little bit of energy. So let's just go ahead and do delta K. That's the change in kinetic energy is equal to the final kinetic minus the original kinetic energy. That should be equal to 1/2. Now our final kinetic energy here is of both objects because they're both moving. So that would be the mass of the cube times the final velocity of the cube. And we need to make sure that we square that. We're going to add that to the 1/2 of the mass of the ball times the final velocity of the ball squared. Then we'll take that whole thing and we will subtract the original kinetic energy. And the original kinetic energy here would be the mass of the cube times the original velocity of the cube. And we need a 1/2 in front of that. And then we will square that velocity. Don't want to square. I think I put too many parentheses around these others. So we'll go back and get rid of some of these parentheses, make this eraser a little smaller. We really just want to square, we don't want to square the masses, we just want to square the velocities. That's my fault. So we have the mass of the cube times the final velocity of that cube squared, and then the final velocity of the ball squared. So now we have everything in the right order. If you go through and do this, you're going to find out that the absolute value of the change in the kinetic energy should be equal to 154 joules. And so that should have been, or should be, pretty easy when you actually try to run through it. If you need to see all of the numbers in there, let's go ahead and do that. So we're going to factor out a 1/2 here because we've got it all the way through. And then we've got the mass of the cube, which is 0.5. 26 was the final velocity of the cube, plus 5 kilograms times 2.4 meters per second, and we need to square it. And then we'll take that and we will subtract, and remember this 1/2 we factored out earlier. So let's go ahead and just do the whole thing to 1/2. So minus, and then this is going to be 0.5 kilograms times 2 meters per second squared. And now we'll do 1/2 of that, and you should end up with 154 joules. For the very last part, letter E, they want us to determine the distance between the 2 points of impact of the objects with the floor. So we need to figure out where these two objects are going to be when they actually hit the ground. So to do that, let's go ahead and erase everything we have here. We'll move this down a little bit so we have a little bit more room. And we need to think about the vertical motion here. So we know that we have our table, and then things are going to come off and then they're going to fall all the way down to the ground. So here we know that the distance in the y is equal to the original velocity in the y times t plus 1/2 times gt squared. And we know that the original velocity in the y is equal to 0, so this term cancels out. And we're left with time is equal to the square root of 2 times the distance in the y divided by the value for gravity. That's actually equal to 2 times 1.2, and then we'll divide that by 10, And so we're looking at a value of somewhere around 0.5 seconds. Now, because we are moving left to right, okay, when we initially go, we know that position is equal to the velocity in the x times time. So we're going to apply this to both of the objects. So let's look at object, the ball. So we'll put B for ball, and then over here we'll put C for cube. We want to find the position of the ball. Be careful because for the position, that is just going to be the velocity of the ball. So that's 2.4 times 0.5. And so that position is 1.2 meters, is how far away it is from the leg when it hits. And then the other one would be the position of the cube, and that's equal to 2 meters per second times 0.5 seconds, and that gives us 1 meter. So they want us to find out the distance between the 2 points of impact. So that would be the change in position, and that would be equal to 1.2 minus 1, and you get 0.2 meters. So you'd have one thing land, you'd add to the other one, and then you have the distance between the two would be 0.2. This would be about 1.2, and then this one would be 1.0 meters from the edge of the table. And then that would give you, you can just use those two numbers then to find this 0.2 meters. And that is the end of this problem.